Okay, we're finding the distance between the points. If necessary, round to the nearest tenth. So since we're going to be using the distance formula, and let me write the distance formula here at the top, you should always write the formula first. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Yeah. And since we're square rooting, you never know, we may we may not get a whole number, and so we will have to use the calculator and then round to the nearest tenth. So let's plug in the values that we know, though. Okay, we got D is equal to the square root of, and we need to kind of identify what is point number 1 and point number 2. Okay, so we can call this x1. I'll do it up top. We can call this x1 and y1, point number 1. We can call this x2 and y2, point number 2. Do it in either order. So then x2 is -8 minus x1, which is 10. Close the brackets and square it, plus y2, we know to be 14, minus y1, we know to be also 14. You can see that part's going to work out to be 0. Close those and square it. And of course, I should extend this out so that you understand that that's getting squared all the way. Okay. Now, how do we simplify it? Well, we say the square root of, and what is -8 minus 10? It is -18 squared plus 0 squared. So what we really get is just 18 times 18, and you can use a calculator for that if you want to. 18 times 18 is 324. And if you don't have a calculator, then you can just do the calculations over on the side. Just don't do them below here, right? So you get then the square root of 324 plus 0, which of course is the square root of 324, which we know since we're finding distance, we're always going to have the positive. And since this 324 came from squaring -18, then we know that 18 is going to be the principal square root, or the positive square root of 324, which is 18. And so the distance is 18. And for this one, it worked out nicely, and we did not need to round it to the nearest tenth. But let's do it. All right, I'm going to start again. I'm going to write the distance formula. Distance is equal to the square root of x2 minus x1 squared. Might want to memorize this because it's handy. I'll provide it for you on the test, but you really should know this one eventually because it's super handy to know. And it logically makes sense. When you can logically make sense of it, you don't really need to memorize it so much as just think about it and know what it should be. Okay. Now, how do we mark this? Well, let's call this x1 and y1, x2 and y2, and you're going to see the same thing happen here. I don't know if you noticed the numbers that they gave us, but we've got 0 for x and 0 for x here as well. So we're going to get the kind of same thing happening as we did on the last problem. But let's follow it through and see. Okay, we're going to put brackets, because because we're putting parentheses in, minus more parentheses, square it. I kind of actually prefer to do it like this, where I just write it out with parentheses, and then I figure out what the numbers are going into it are later. Okay, so x2, 0, minus x1, 0, y2, 12, minus y1, 3. And then continuing on, we say that becomes then the square root of 0 squared plus 9 squared, or the square root of 0 plus 81, which is the square root of 81, which is 9. That's the distance between those 2 points. Okay, keep going. I bet it'll get a little more complicated in the last problems. All right, here we go. Now we have different x and y coordinates for both of these. So let's do it. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And if we then identify the points as being point number 1, x1 and y1, point number 2, x2 and y2, and we can sub them in easily. Okay, we're going to put brackets, parentheses. Remember, these brackets are representing these parentheses that were right here. Okay, and these parentheses here are because we're subbing in variables. We're subbing in values for the variables that we were originally given in the formula. Okay, so close that, square it. So what we're going to do is we're going to subtract those values and square it. Plus y2 minus y1 squared. And what are those values? Well, x2, negative 2, minus x1, 6, y2, 4, minus y1, negative 2, and when we simplify this, we get negative 2 minus 6 is negative 8 squared. You need those parentheses around that because this is not equal to this. The first one says take the negative of 8 squared, which is 64, negative 64. And the second one says square negative 8. Negative 8 times negative 8 is positive 64. Those are different. Okay? They are not equivalent, and you can't leave off the parentheses around this negative 8 because otherwise you're just squaring the 8 and not the negative 8. Okay? Got to trust me on that. Write it every time. You'll get in the habit of it if you do it every time. If you don't do it every time, if you don't hold yourself to it, then you're not going to get in good habits like that. Now, square root of then 64 plus 36, or square root of 100, and that is a nice, neat number 10. So we have the distance between these 2 points of 10. Box the answer. Okay, one more. Let us start out by writing the distance formula. Distance is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and you see that you got to do the subtraction before the squaring, so that's why the parentheses are there. Now, we need to put brackets. We're going to sub in a value for that, sub in a value for that, plus brackets, sub in a value for that, sub in a value for that, And let's sub in those values. Well, let's identify them first. We can call this x1 and y1, x2 and y2. And so x2, 12, minus x1, 0, y2, 3, minus y1, 5. And simplifying this, we get 12 minus 0 is 12 squared, plus 3 minus 5 is negative 2 squared. .44 plus 4, and that equals the square root of 148. Now, I happen to know that because 144 is a perfect square of 12, and 169 is a perfect square of 13, this is somewhere between 12 and 13. So I'm going to actually just do it on the calculator. I'm going to type 148 and square root it. And I get 12.16. So I'm going to write approximately equal to, because at this point I'm not writing it perfectly. Although I haven't rounded it yet, I'm showing you what the digits are, just so you can get a sense of it. Okay, and it continues on, dot, dot, dot. How do we round? Well, it's telling round to the nearest tenth. So what we want to do is we want to say, what's in the tenths place? And then, is what's in the hundreds place right after it, enough to be considered another half a tenth or more? And if it's 5 or higher, you say, yeah, it's another, we can count that as another tenth because it's half or more than another tenth. So it's a 6. So we can then say it's approximately equal to 12 point, the 1 goes up to a 2, and then everything drops off. Okay, so the distance is approximately equal to 12.2 units. And we're done.